Good morning, class. Today we will be talking about the geometry of spirographs.
Amazing.
This amazing spirograph toy was originally invented in the late 1800s, but wasn't first advertised until the 1908 Sears catalog. In 1967, it was nominated and won Toy of the Year in the United States, and was again nominated in 2014. Now, let's begin with where our spirograph starts. We can see here that our little circle has center C2 with radius little r, while the big circle has radius big R. We will trace our tracing point P as little circle travels around the big circle. The distance between C2 and P we will call M. We will also say that C2 and P have these coordinates. The last thing we need is to name a point T, which will be tangent to our little circle and our big circle as the little circle travels around, and point A, which will travel clockwise around C2 as C2 travels counterclockwise. The spirograph consists of two circles. One of the circles remains stationary while the other rotates around it. The rotating circle can either rotate within or around the outside of the stationary circle. If the spirograph rotates around, the curves are called epitrochoid. If the spirograph rotates within, we create what are called hypotrochoid curves. These curves are a subcategory of roulette curves. A roulette curve is created with any two curves, whether they be parabolas or circles. Okay, now we will look at what our smaller circle does as it rotates around the bigger circle. We will need to name a few things before we can move on to the math. Let's make our smaller circle into its own relative system. In this system of x prime and y prime, T will make an angle alpha with the x prime axis, while P makes an angle beta with the x prime axis. We will also name point P within this relative system. We can also note that if we want to find P within the larger system, we can take the center of our smaller circle and add it to the coordinates of P within the relative system. This will give us the point P at any point of our spirograph. Now we can get to the fun part. Let's look at the math of the spirograph. Because we know our two circles roll without slipping, we can say that the two arcs are in fact equal to each other. We can then come up with an equation for beta in terms of alpha. We can also come up with a periodic function for the point of our small circle, as well as P within the relative system. Now, as I said before, we can in fact add these 2 points to find P at any point in time within the larger system. We have done so here. As you can see, we can now find an equation for P as xy at any point in time. And it's simply based off of the radii of our two circles, the distance from our tracing point P to the center of our small circle, and angle alpha. Now we can find the tracing point P at any point in our spirograph. We have now learned how to graph a spirograph.